Good evening and welcome to the Writer's Block. I'm your host, John Ronan, and as you know now, because we're in our 25th season, I interview writers about their craft, what they're working on now, what they've accomplished in the past, what they might be planning for the future. We have on poets, we have on novelists, we have on short story writers, editors, all kinds of writers, sometimes science writers. We also have a little room now and then for other kinds of artists. We have had on sculptors and musicians, actors. It's a pretty wide net. So if you have an idea for a guest who might be right for the Writer's Block, watch for our address at the end of the show. We'd be glad to get your suggestions. I also want to remind you that the Writer's Block and all other original programming out of Cape Ann Television is a product of cable access television. You don't get that with Dish. So remember that if you're tempted to switch. I'm very happy to say tonight we do have a writer, and this is a very rare occasion. We're lucky to have a science writer on tonight, William Waller from Rockport, who was a guest on the show about 10 years ago with an earlier book. He is an astronomer, and we're going to be talking this evening about his new book, The Milky Way, An Insider's Guide. I'm going to hold that up so we can get a good view of that. Ryan is telling me that it looks good. William Waller, thank you for being with us on the Writer's Block.
Thanks for having me again, John.
It's been a while.
It's been a while.
I want to ask you, before we get to the book and the details, about your background. Are you originally a Rockporter?
That's right. I moved up here with my family around the age of 8. When was that? 1958, 1959. And had my education here at Rockport schools. Went away to seek my so-called fortune, doing all the higher educational stuff. Came back 25 years later with my own family, and living in the house I grew up in.
And we were lucky enough to have your mom on the show, writing about Rockport history.
It was in the previous century, and I think it was a book which was a compilation of stories from Gloucester fishermen's wives and other Gloucester ladies.
Yes. So your family is well acquainted with Cape Ann TV.
Yes, it's always a delight.
When you went off into the world, went over the bridge, where did you go to school?
University of Arizona, because I already knew that I was interested in astronomy due to my childhood here, where I could see the night sky. And so I went to University of Arizona for my bachelor's degree, and then came back to Massachusetts for my master's at Worcester Polytech, and then after a bit of work doing the doctorate at University of Massachusetts.
What did you major in as an undergraduate? Can you get an astronomy undergraduate degree?
In certain schools you can. I did a double major in physics and astronomy. Astronomy is applied physics in many ways, just like many other fields.
So that means a lot of math too.
Sure.
To back up the physics.
Sure. But it's basically algebra, trig, and calculus. You don't have to go that much farther.
The book is The Milky Way, An Insider's Galaxy. And when was this published?
Last year, April 2013.
April 2013. I was fascinated first by your recollection in the book, and something you touched on just a minute ago, of looking at the stars as a child and getting hooked early.
Yeah.
Can you tell us about that?
Yeah, I was 10 years old after we had moved when I was around 8. And it took that long for me to finally get used to my surroundings and look up. And it was some night around this time of year because I saw the Milky Way. And I think I was looking towards Cygnus and Cygnus and Cassiopeia, where you have the northern cross of Cygnus, excuse me, and the W of Cassiopeia.
Big kind of open flat W.
But there was this other thing that I had never noticed before, and that was the Milky Way.
And it's brightest in the fall and early evening in the northern hemisphere, is that right?
Well, it's also overhead. And so I think I was in my driveway, and I looked up, and there it was. And so that was very alluring.
And there wasn't a lot of light pollution?
No. And it's gotten worse, but not that much worse.
Did you know then, when you were 10, that you wanted to study?
I was
That-
definitely fascinated by it, yeah. And when I went off to college, I thought that's what I wanted to do. My college career was a little bit checkered. I think I coasted the first 2 years and paid the price. But the second 2 years, I had experiences which helped me along. And then in the 2 years I took off between college and grad school, that really affirmed my interest. I was a security guard at a Lipton tea factory in Santa Cruz, California.
A Lipton tea factory.
Yeah, yeah. And it was the midnight shift, the graveyard shift. And so there's a lot of time to do nothing. And I started reading short stories, Mark Twain, and longer works by Mark Twain. But then I got into the astronomical literature and really haven't looked back since.
You had gotten a gift from your parents of a telescope.
Oh, at the age
earlier.
of 10, yeah. Yeah.
Tell us about that experience a little bit.
Yeah, they gave me a little spyglass for Christmas, and I padded out into the snow in my galoshes and tried to make it work. And it's hard to actually get a planet or a star in view. It's not like binoculars. It's usually a narrower field of view with a spyglass. But once I got one, I'd prop it up on the fence and stuff. I saw these big objects through the eyepiece. And I thought I had really found something. But it turns out that the telescope was out of focus. I didn't know how to focus the telescope. And so once I focused it, there was the star, yes, but it was just a pinpoint. Maybe a little bit of color, but it was just a pinpoint. And I knew enough that that star was a sun. And so I made the conclusion that if that star is a sun and it's just a little pinpoint through this telescope, it must be really far away. And so kind of my universe exploded at that point.
Just as what happened in, I guess, the 16th century when
With Galileo.
when astronomers first began to realize the depth of this thing out there, the universe.
Yeah, it took a long time for them to prove it, that those stars were suns and the sun was a star. And that the first star whose distance was measured was around in 1830 or so. It was a hard thing to do.
Hard thing to comprehend.
Yeah, well,
So-
actually, to actually get that measurement, to actually determine that
Yeah.
star.
With a parallax system?
It was the parallax, yeah. You can do it with the thumb and your two eyes. If you look at a thumb, I'm looking at you with my thumb, and I close one eye, and I see the thumb on one side of your face. And if I switch eyes, the thumb's on the other side of your face. And we see the same thing when the Earth goes from one side of the sun to the other in its orbit. And we'll see a nearby star, the thumb, shift in position with respect to more distant stars. That's the parallax effect.
Even though that distance of maybe 190 million miles between one side of the orbit is infinitesimal almost compared to the
Right.
distance of the...
Right. I think the nearest star is close to 300,000 times farther than the Earth-Sun distance.
Would you say that again for our audience? I want to make sure they get
I think that's right. 1 parsec, which is a unit of distance, I know is 206,265 times larger than the Earth-Sun distance. And so I'm just, the nearest star is just a little more than a parsec. It's about 4 light years away.
4 light years, and that's the distance that light would travel in 4 years.
That's right. So we see it as it was 4 years ago.
Yeah.
Well, not you and I here. You have to go to the southern hemisphere. It's the Alpha Centauri system. It's 3 stars.
I'll do that when it gets cold.
Oh, you
I
should go to
won't
the
get down.
southern hemisphere. It's glorious.
I've never seen the Southern Cross. I would like to see the Southern Cross.
Yes. My great aunt was a missionary in India for 50 years. And by the time I got to know her, she was an invalid at a Methodist nursing home. And because she was blind. But I went to her bedside and told her that I want to be an astronomer. And she says, "Oh, you must go to India and see the Southern Cross." And so eventually I did go to India and I got to see the Southern Cross. But there's a whole bunch of other really cool things. down there in the southern hemisphere, including the center of our galaxy, looking towards Sagittarius. That's a southern object. We can see some of it, but it's way on the horizon.
You have included in your book, I would like to get some of the details, some wonderful images of some of these black and white and color, which I know is quite an expensive proposition for a book. I'm going to hold this up, this page, and I'd like if you would tell me what, is that showing up well, Brian? Or Ryan, excuse me. What am I pointing to here?
You're pointing at a Hubble Space Telescope image of the Orion Nebula, Messier 42. It is the nearest site of burgeoning star formation to us. It has a cluster of about 1,000 stars, and 4 of them are real barn burners, really massive, luminous, hot stars, which are really doing a job on the surrounding nebulosity, what was once cold, dark molecular gas that formed the cluster of stars now is being zapped by the ultraviolet light from those stars.
What's the distance approximately?
1,500 light years.
So what we're seeing here is from the year 500 AD approximately.
Okay.
Is that right?
Sure.
1,500?
I can't make change either. But that sounds about right.
So it's old. Old light, old light because
yeah,
it's
1,500 years. What's really cool is that the hominids, our forebears, 2 million years ago, did not see that. That's a naked eye object below the belt of Orion, the 3 stars that make up the belt of Orion. It's in a kind of a uncomfortable spot. It makes up the sword of Orion, but I would not want to put a sword where it's dangling. Okay. Yeah. Anyway. The nebula is a naked eye object, and it used to be called a smoking star by Native Americans because it looked a little bit fuzzy to the unaided eye. But the hominids, 2 million years ago, before Homo sapiens, other hominids, they would not have seen it because the cluster had not yet formed. It's a relatively new cluster. It was formed about 1 million years ago. That's young.
Yes,
That's
we're talking
wicked
about
young.
great space and great distance and time as well.
Well, just think about our own sun. It's 4.6 billion years old. That's more than 1,000 times older.
I want to look at another color image, if I could, a beautiful blue image that I want to point to. Could you tell us?
I could tell you a lot
is?
about that one. That's an artist's conception of our Milky Way as it would look like as viewed from afar, away from the galaxy, above the galaxy, God's eye view of the galaxy. That's what we think it looks like. We don't really know because we are insiders. The Milky Way and Insider's Guide, it's a bit of a cruel joke. We're kind of like stuck in a forest, lashed to a tree, and trying to figure out the lay of the land. It's very hard to do. That's what the best guess that scientists have, that there's a central bar, okay, of older yellowish mellow stars. They've been around a while. The hot blue upstarts have already gone away. They've blown up. They're gone. So that's your central bar. And so that's a relatively new discovery, that we have this oblong structure in the center. And then there's 2 spiral arms in that image, but some astronomers think that there are 4 spiral arms.
And we're out in one of those.
We are sort of near one. We're in supposedly it's what's called the Orion Spur, which is kind of like in between 2 of the major spiral arms.
I did want to mention the color and also a lot of the black and white images in here. Also, the book has a good index and something I find valuable because my background is not in science, a glossary, which has these beautiful understated terms. I mentioned one of them to you before the show, the local group.
Yes.
What would you tell us what the local group is?
The local group of galaxies consists of about 100 galaxies dominated by 2 major players. One of them is the Milky Way galaxy, our home galaxy. The other one is the Andromeda galaxy, which is 2.5 million light years away. Okay, millions. We've been doing thousands, now we're in millions. It's a galaxy you can see naked eye from the northern hemisphere this time of year.
The hominids would have been able to see that.
Yes, they would have had no problems.
2.5 million years ago.
It's been around a while. It's been around as long as the Milky Way, around 12 billion years. It turns out that most galaxies are about as old as one another. They were all formed around 12 billion years ago, just a few billion years after the Big Bang, the start of everything. But anyway, the local group, you wanted to ask about it. Each of these galaxies have a lot of smaller galaxies buzzing around them, kind of like bees around two hives. And that makes up our local group. Now, you might not think of that as very local, but it's one of several groups that comprises the next, well, a structure called the Virgo supercluster. And now you're talking about something which is in the tens to hundreds of millions of light years. That's a big piece of
And
real
the
estate.
Andromeda is the closest galaxy to us.
The closest major galaxy.
2.5
million.
light years.
Yeah. But you can see it naked eye
Yes.
on a dark, moonless night.
It's not, yeah, you don't see it doesn't look big. But I don't want to take words out of your mouth by talking about the structure of the book. I just wanted to mention the glossary and the index. Tell us about the outline of the book and how you first conceived of writing the Milky Way, an Insider's Guide.
Well, I wanted to give an overview first off, and that's that first chapter, which introduces the Milky Way. It's our view of the Milky Way, quadrant by quadrant around the sky. And so that's what the first chapter does. The second chapter is really a history of our consciousness of the Milky Way, going back to prehistoric times. Obviously, it's an abbreviated history, and it was the most challenging part of the book to write, to give the major players their due, and also to find the figures, historical figures, to bring it alive. The third chapter has to do with multi-wavelength astronomy. We don't just look at the Milky Way visibly, at visible wavelengths, but we also look at all the other wavelengths that are available to our technologies, such as radio wavelengths, infrared wavelengths, visible, ultraviolet wavelengths, X-ray wavelengths, well, X-rays and gamma rays. All of those are available to us now.
I think it's not generally known that our visual spectrum is part of the huge electromagnetic spectrum, but a very, very small sliver of it.
Yeah, it's a
and there's
tiny
just
little...
stuff all around us going through our brains, and
Right.
and it's invisible to us.
That's true.
But it's
Snakes supposedly have some infrared capabilities. We have some, our skin is an infrared detector. So when you're out on the beach sunning yourself, you will feel the infrared. You will see the sun, obviously, perhaps through your closed eyelids even. And then you might experience the burning effects of the ultraviolet. So we are somewhat multi-wavelength detectors, but not nearly as good as what we've become
so you
technologically.
talk about the machines
Right.
that we use have created to detect all these other ranges of
Right.
frequencies.
And each range of frequencies or wavelengths give us a new window on the types of objects that are out there. For example, in the radio, you can see these clouds, these massive clouds of very cold gas, full of molecules. And they're the biggest objects in our Milky Way galaxy. And they're very important because those are the places where stars are formed. And then at shorter wavelengths, higher energies, such as ultraviolet and X-ray, you can see the most energetic objects in the Milky Way. For example, closely interacting binary stars. Perhaps one of them is a white dwarf or a neutron star, and there's a material going from one star to this compact star, and there's all sorts of repercussions, explosions, eruptions, and that is often in the X-rays.
I see some beautiful images of that kind of phenomenon.
Right, and then there's the exploding stars themselves, the supernovae, and the supernova remnants, and they're you can see them at X-rays and in infrared and visible, and now the NASA folks have combined the light from their various observatories into these glorious pictures.
So you trace that progress of knowledge and discovery through the initial chapters.
Right.
I want to touch on the end of the book, but what else do you cover then after?
Then we get into basically stars, because they're very important. If you think of a galaxy as like a big ship of the night, and it is the essential unit of matter in our universe. We live in a Galaxian universe. If you think of galaxies as like ships in the night, then you might think of the stars as the engines in that galaxy, and they're the ones that light up your ship at night. Without stars, it would be a pretty dark sky. And also stars are very important because that's where the planets are made as well, including our own planetary system, the solar system. And so I go through the methods of trying to find distances to stars and then characterizing stars, because stars are different. You can actually see that on a nice night. You notice that some stars are different colors.
Different colors, yeah.
Yeah. And it turns out that the properties of stars trend very much with the mass of the star, the initial mass of the star. The greater the mass of the star, the brighter it burns, and the shorter it lives.
You have a good some graphs in there. The main sequence stars is really a steady line.
Yes, there are families of
amazingly
stars.
consistent.
Right, the stars that are still burning hydrogen in their cores, fusing hydrogen into helium, they lie in this particular diagram known as the Hertzsprung-Russell diagram on this so-called main sequence. So that's one family of stars. And then there are other families. There are the giants, which are brighter for their temperatures, for their colors, if you will. And then there's the supergiants, which are even brighter for their colors. And then below the main sequence are the white dwarfs, which are fainter for their colors. And that's because they're little things about the size of Earth.
I just got the 5-minute signal from Ryan. I want to get to one final point. You finished the book about whether the discovery of all the exoplanets that's
Right.
just booming.
It's incredible.
Means that we're not alone. Are there other conscious beings out there?
Well, we certainly know that there's a lot of planets out there. There's thousands. There's 2,000 planets that have been pretty much confirmed. And we've only looked closely at a particular patch of sky between the constellation of Cygnus and Lyra. That's the Kepler mission. It's done an incredible job finding these planets and characterizing them to some degree. We're at the point where we can characterize them according to their size and perhaps their mass, if there's follow-up work done from the ground. And with that, you can get an average density for the planet. And so we're now beginning to see rocky planets, watery planets, and gaseous planets.
Smaller.
Well, just the densities are, a gas planet's a very low density planet, whereas a rocky planet is a higher density planet. We can figure those things out. And then the question is, are they in the so-called habitable zone around their host star? And that's the zone where surface water would be liquid, in liquid form, because we think that water is important for biological processes. And so right now we're just at the ground floor, at the very beginning of characterizing planets and planetary atmospheres as well.
Based on the discoveries so far, are there necessarily in the galaxy trillions of planets of one kind or another?
There's about 100 billion, there's about 10 to 100 billion stars in the Milky Way, and most of them probably have planets of some kind. So there's a lot of planets out there. And of them, some of them will be going around a good star, a star that won't blow up anytime soon, and might be in this zone. And if I was a betting man, which I am, I would say that there is definitely microbial life out there. As for animal life, more complex life, that's very hard to tell.
I just got the 3-minute signal. This is a Princeton University Press book, and it's available online.
Yes.
And where else? It's available-
Amazon, all those sellers.
Princeton, Barnes
and-
and Noble, everywhere.
And I encourage your viewers to also go to your local bookstore and just order it, because it would be nice to keep
Okay,
those
go to the
folks
bookstore in
going.
Gloucester or in Rockport,
Right.
and order The Milky Way and Insider's Guide.
And I also will be talking about it on
yes.
November 6th at the Sawyer Free Library in Athenaeum, and I'll bring some books to sign. That will be at 7 p.m.
November 6th,
November
7 p.m.,
6th.
Sawyer Library here in
Gloucester.
Gloucester. Yes, indeed. Thank you,
Well, thank you.
William Waller, for being on the show again. I very much appreciate you coming down and talking about The Milky Way and Insider's Guide.
Thank you so much, John.
Thank you. I want to thank you in Cablecast television land for being with us as well. If you've learned something about the galaxy and its mysteries from Dr. William Waller, then the Writer's Block has done its job. Hope to see you again next week on the Writer's Block. Good night.